Hello everyone, myself Mr. Kiran Chinswalkar, lecturer in Mechanical Engineering Department from Praveen Patil College of Diploma Engineering and Technology. Today we see the third chapter, Casting Processes and Plastic Molding, Part 4. Learning Outcome. After watching this video, you should be able to know safety practices and precaution in foundry shop. Second is different types of furnaces, and third is various casting defects. In this slide we study safety practices and precaution in foundry shop. First precaution is use personal protective equipment. First point, use heavy cotton suit to protect against hot gases, dust and burn. Second point, use safety shoes. Third point, workers should always wear full face shield and safety glasses to reduce or eliminate the risk of eyes or face injury. Second precaution you should take, reduce impurities in metal. First point, molten metal emits fumes. Any impurity on the surface of the molten metal increases the risk of breathing problems. So, metal used should be in a pure form. Impurities also increases the dross that must be removed, thereby increasing the workers' exposure to harmful substances. Next, third safety practice is know your melting. First point, different metals have different characteristics like melting temperature. Second point, alloy elements like lead, zinc, mercury, barium is especially dangerous. Third point, it is better to know the health risks associated with handling these elements before exposure happens. So, take all necessary precautions before handling them. Fourth point, inspection. Check the condition of equipment, condition of furnace wall, fuel lines, burners and pouring equipment regularly and do the periodic maintenance of it. Point number 6. Check for leakage of molten metal and gases. Point number 7. Ensure water or moisture have not managed to get below the surface of liquid metal in the furnace. Water below liquid level in the furnace is a ticking time bomb. Therefore, inspection of furnace is essential prior to melting. Point number 8. Keep dry sand and shovel ready to put out fire or to control metal spills. Next safe practice, point number 9 is first aid. First point, despite the best planning, precaution and care, sometimes accident happen. Second point, it is advisable to be prepared for the worst. Third point, basic first aid may be need to be administered before help arrives. Point number 4, the workplace must have a working phone to call for emergency services. Point number 10 is training. The commitment of management, effective communication and timely training is important to ensure the safety and health of all employees and the protection of the environment. Next point is melting processes. The selection of furnace depends on following factors. First point is temperature of molten metal required. Point number 2, rate of molten metal required per hour. Point number 3, method of metal pouring. Point number 4, economical consideration such as initial cost, running cost, fuel cost, etc. Point number 5, cleanliness and noise level. Point number 6, quantity of metal to be melted at a time. These are some factors in which melting processes we are selected. Now we see types of furnaces. For remelting metal in foundries, following furnaces are used. First is a crucible furnace. Point A, pit furnace, coke fire furnace. Second, tilting furnace, oil and gas fire. Second point, metal pot furnace. And third is a cupola furnace. Now we see cupola furnace. Cupola is a furnace in which pig iron along with scrap is melted and iron casting are prepared. Cupola furnace is simple in construction and operation, continuous in operation, economical in working and gives high output. Now we see construction of cupola furnace. The cupola furnace consists of vertical shell built up of steel plate about 8 mm thick lined with refractory fire bricks. Second point, it rests on a circular plate which is supported above the floor by 4 cast iron legs suitably spaced so that hinge bottom door or drop bottom can swing freely. Point number 3. The door is held in horizontal position by a vertical prop. Next point. It can be dropped to empty the furnace. The charging door is located about halfway up the vertical shape and top is covered with a metal cover or spark arrestor. A little above the bottom, a circular compartment called a wind box is provided. The blast pipe enters this box which forces the air completely around the wind box from blower by means of wind pipe. Number of tubes are provided in the wind box to supply the air to the furnace. A charging door is situated 3 to 6 meters above the tubes through which metal, coke and flux are fed to furnace. The shell is continued for 4.5 to 6 meters above the charging door to form a chimney. Spark arrestor at the top allows only smoke to escape from chimney. These are construction of the cupola furnace. Cupola furnace is used for continuous melting of the iron. In this slide, we study direct arc electric furnace. An electric arc is a struck between carbon or graphite electrode which produce intense heat. The impurities are oxidized from the charge by melting and absorbed by slag. The slag is run off by tilting the furnace. The furnace consists of a steel cylindrical shell with a spherical or flat bottom. The bottom is mounted on rollers so as to enable the furnace to be tilted by operating a hand wheel. The charge is contained in a bowl-shaped earth lined with suitable basic material like magnetic bricks. There are two spots opposite each other, one for pouring the molten metal and other for taking out the slag. Three large vertical electrodes are arranged in a triangular pattern, which can be raised or lowered by an automatic device. The charge consists of steel scrap and iron oxide in form of iron ore. After charging, the top is closed and electrodes are lowered and current is switched on. A powerful spark is produced between electrode and metallic charge. High temperature of about 2000 degrees Celsius is produced. This intense heat melts the charge.
To get desired composition, alloying elements are added. The process is suitable for both ferrous and non-ferrous metals. This process is costly because of high cost of electricity, and so it is used for making high grade alloy steel, heat resistant steel and stainless steel. In this slide we study centrifugal casting. In this process the mold is rotated at about 1500 rpm and molten metal is supplied to the mold with centrifugal force. The metal flows under pressure into the mold cavity by centrifugal force. The impurities, being lighter in weight, are left behind at the center so sound casting will be produced. In this slide, we study true centrifugal casting. Figure shows the horizontal casting machine used for casting pipes with a sand line mold. At bottom there are four rollers driven by power on which a cylindrical flask or box containing mold is placed. Top roller press the flask and are raised by removing the flask when metal solidifies. The rotational speed of the flask is so kept that metal by spread properly over the entire mold wall due to centrifugal force. The force also holds the metal unit it solidifies. The thickness of casting wall can be controlled by controlling the amount of molten metal poured in the mold. The method is useful for casting hollow cylinder objects such as pipes, liners, gun barrels, etc. In this slide, we study casting defects. A large number of defects are observed in sand casting. Second point, they may be due to the different faults in molding and core sand, molding techniques, casting processes, impurities molten metal, etc. Point 3. The defects can be controlled in casting but cannot be totally prevented. First defect is blowholes. Blowhole occur in a casting due to liberation of gas during solidification and trap inside the casting. Second point, they are caused due to entrapped bubbles of gases in the metal. Point number 3, the defects that are visible on surface are called open holes and the holes which are below the surface and not visible are called as a blowholes. There are probable causes for blowholes. First cause is excessive moisture. Second cause, low sand permeability. Third cause is fine sand grains. Fourth cause is improper venting of mold. Fifth cause is excess use of organic binders. Sixth cause is too hard ramming. And seven cause presence of gas producing ingredients. For these probable causes, there are suggested remedies. First remedy is control of moisture content. Second, use of rust-free cheese, chaplet and clean inserts. Third, bake core properly. Fourth, ram the mold less hard. And fifth, provide adequate venting in mold and cores. If you use these suggested remedies, then we cannot not 100% avoid the blowholes, but we can avoid in a proper way. Second defects occur in a casting is dirt. These are particles of dirt and sand embedded in a casting surface. Second point, it is due to improper handling of mold, presence of sand and slag particle in the molten metal, etc. Point 3. To avoid these defects, dirt may be prevented from entering the mold cavity by proper fluxing and use of dirt traps. Probable causes for dirt is: first is faulty getting, second is faulty pouring, third is inferior molding or coarse sand, fourth is a soft ramming of mold, and fifth is rough handling of mold and core. Suggested remedy for these defects is: first is modify gating system, second improper pouring to minimize turbulence, third use of superior sand of good strength, and fourth provide hard ramming. These are suggested remedies for this casting defect. Next casting defect is drop. A drop is irregular deformation of casting. Second point, it occurs when the upper surface of mold cracks and piece of sand fall into the mortar petal. This is due to low strength and soft ramming of sand, insufficient fluxing of molten metal, land, sufficient reinforcement of hanging section, etc. Probable causes for the defects is: first cause is low grain strength in molding sand and core, second too soft ramming, third inadequate reinforcement of sand and core projection. Suggested remedy is: first is increase grain strength of sand mold, and second provide harder ramming. Next defects is shifts. First point, it is a misalignment of top and bottom parts of mold. Second point, these defects occur at parting line. Third, it results in mismatch of the casting, incorrect dimension or incorrect location of holes. Shift is caused by misalignment of flux, cores, etc. Probable causes for these defects is: first is worn out or bent clamping pins, second misalignment of two halves of pattern, third improper support of core. Suggested remedies for this defect is: first is repair or replace the pins for removing the defect, second repair or replace the dwell pin which causes misalignment, third provide adequate support to the core, and fourth increase strength of both mold and core. These are such remedies for this defect. Next defects occur in a casting processes is warpage. These defects occur during or after solidification. Second point, it is unintentional and undesirable deformation in a casting. Third point, due to different rate of solidification in different section of a casting, stresses are set up in adjoining walls, resulting in warpage in this area. Fourth point, large and flat section or intersecting section such as reeds are prone to warpage. To prevent warpage is to produce large area with wavy, corrugated construction or add sufficient ribs or rib-like shape to provide equal cooling rates in all areas. Probable causes for this defect is: first is continuous large flat surface on casting indicating a poor design, second two-dimensional solidification of casting. Suggested remedies is: first is follow principle of sufficient directional solidification, second make good casting design. Next defect is fin. First point, it is thin metal projection on casting. Second point, it is caused due to incorrect assembly of molds and cores, flux not properly clamped, etc. Point number 3, To avoid fill, use sufficient weight on the top part of mold so that the two parts fit tightly together and ensure correct assembly of mold cores. Probable cause for this defect is first is misalignment of molding box, second incorrect clamping of molding box. Suggested remedies first is ensure correct assemble of molding box. Second, place weight on top of molding box. Next defect is misrun or cold shut. Point number 1. Misrun occur when molten metal fails to fill the entire cavity of the mold. Second point, an incomplete casting result in a misrun. Third point, a cold shut is formed due to the imperfect fusion of two streams of metal in the mold cavity or unequal section of a pattern assembled together. Fourth point, the defect appears like a crack or seam with rounded edges. Point number 5, both the defects are caused due to lack of fluidity in molten metal, faulty design, improper gating system, etc. Probable causes for this defect is first is lack of fluidity in molten metal, second faulty design, third faulty gating. Suggested remedies is first adjust proper pouring metal, second modified design, third modify gating system. I hope you understand this presentation. Thank you.